We are live now, and today's concept which we are planning to discuss is the concepts of stemming. So here we are going to quickly get started with the concept of stemming, wherein you all will get to know how you can quickly reduce the inflected words and reach out to the base word. So this is a very important concept of unsupervised, unstructured machine learning, wherein you will grab content from different sources like audio. You can grab information from various options like images, image files, audio files, PDF documents. And whenever you encounter a word which is inflected with an affix, your objective is to use stemming algorithms and to remove that information out. So to quickly get started with the concepts of stemming, let me just introduce you with the official definition of stemming. So here you can see that stemming is the process of reducing inflected words to their word stem. You can also convert them to the base or the root form. So now it will be possible that when you extract content from a normal text, then you may get some word written form. Now what you have to do is, from this word written form, you have to remove the affix out and you have to reach out to the root word or to the base word. Now, before proceeding any further into stemming, I would like to share an image with all of you so as to give you a quick example of what stemming looks like. So here I'm sharing one information with all of you. Now, when it comes to stemming algorithms implementation, your objective today is to perform stemming on this original text. So let's say you have extracted some text content which includes some keywords like caring, cares, cared, caringly, and carefully. Now here you can see that on the word care, the root word here in this case is care, and over the care we have added some affixes like ing. We have added an affix like s. We have put in affixes like cared. We have put in affix like ly. We have put in affix like fully. So our objective is to identify these, and you have to remove these affixes out. Okay. So when you remove this affix out, you will reach out to the base word or to the original word. That's what you will be doing under the concept of stemming. So there could be so many steps possible. There are multiple algorithms which can actually help you identify the affix and remove the affix out. So some popular algorithms for this is Porter stemming, Lancaster stemming, and Snowball stemming. In today's session, we will be implementing all these three algorithms in order to identify original words or root words out of the text content extracted. Now here, as you all can see, we will be removing these following keywords from the text content, and we will reach out to the original word care. So as you all can see, there are multiple stemming algorithms like Portal stemming algorithm, Lancaster stemming algorithm, and Snowball stemming algorithm. There are differences with respect to accuracy, speed, and the level of how it is used. Your final objective is to reach out to these base words. Okay. So here you can see that there are certain limitations with Porter. Then you can see that Lancaster has actually tried to identify some real word, but it is not accurate for what words we are writing. Now, the best algorithm used today in the industry is Snowball stemming algorithm, using which you can reach out to the rightmost word. So our objective is to identify these right words after removing affixes from the original word. Now to do this, how we are going to do, we will be using certain algorithms, and these are the three algorithms which you guys will be using. So these algorithms are, the first one is Porter algorithm, which has been introduced by Martin Porter in 1979. This algorithm is oldest and most widely used. And here you can see that it involves highly computationally intensive steps. So there is an improvement to this algorithm available in today's scenario, and that algorithm is known as Snowball Algorithm, which is again written by Martin Porter and Richard Bolton in 2001. So this is one good algorithm which has improved version of Porter's original stemming algorithm. But you don't worry, you will be implementing all these three algorithms. Apart from that, there is one more algorithm written by Krish D. Pace in 1990 known as Lancaster. Lancaster is fast and aggressive. However, the words are not intuitive for shorter words. Okay, so let's quickly have a look how you're going to implement all these three algorithms and how you're going to filter stems out of the text content. So guys, I think the concept is clear to everyone that what all you are going to do. You're going to have some text content available. You're going to extract the content. After extraction of the content, you're going to clean it. And after cleaning, you will be performing this steps of stemming. Once you have implemented step of stemming, machine will be able to identify what is the meaning of that word. Okay. So now let's quickly proceed further and let's see how we will be implementing all these three algorithms in order to reach out to the most valuable word, the stem word. Now, to do that, let's quickly proceed to the next step. And one more thing I would like to quickly share. I would like to complete that Wikipedia article, which I have shared with all of you. So I'm taking you again to the official definition of stemming. And you can see that stemming is the process of reducing inflected words to their word stem or to the root stem. Now, let me just quickly take you to a little bottom in order to quickly specify what kind of things are actually done when it comes to the algorithms which we will be using. So there are multiple algorithms like suffix stripping algorithm, wherein from the words you have to remove ed, you have to remove ing, you have to remove ly, and there are so many cases. Now, this step is pretty important, as if after completion of stemming, you can quickly perform lemmatization and you can perform execution of n-gram analysis. So this is what something which you will be doing known as affix stemmers, which we will be using. And there will be certain algorithms. So there are three algorithms which you guys will be using today. So one is Porter, second is Lancaster, and third is Snowball. Now you can see that here at the bottom, the Snowball stemmers have been compared with commercial lexical stemmers with varying results on this article, and you can quickly have a look. So Snowball stemmer, which you can see here, you will get to know how you can quickly implement it. Now here you can see that as far as applications are concerned, stemming is used as an approximate method for grouping words with a similar basic meaning together. For example, a text mentioning daffodils is probably closely related to a text mentioning daffodil. But in some cases, words with the same morphological stem have idiomatic meanings which are not closely related. A user searching for marketing will not be satisfied by more documents mentioning markets but not marketing. So information retrieval, domain analysis, and use in commercial products is one of the most important area wherein you can implement your stemming algorithms and you can complete your objectives. Now, you guys are going to implement all these things practically using Python programming language. And at the end, you're going to get the original words, out of which the noises as well as the stemming part, the affixes will be reduced and removed. So let's go for it. I have given you a quick definition of all the algorithms which are available, as well as how will you be doing stemming. So I'll take you to my collab. Let's go to collab.research.google.com. And here on Collab, we'll get started with coding. So guys, when you come to collab.research.google.com, you have to start new Python 3 notebook. Okay, so I've got a message. Anaconda will not be used today. Jagjeet, that's not required. If you want to use Anaconda, you can use that also. But today we will be using Google Collaboratory. So guys, all the people, those who are connected with us online, feel free to post your questions on chat boxes so that we can quickly read out those questions and we can help you out. So these questions can be posted by all the participants who have joined us in the live classroom, as well as all the people, those who are connected on Facebook also can quickly share their questions and we will be happy to help you out. So guys, as you all can see, Google Collaboratory has been opened and today we will be implementing the concept of stemming. Okay. Just to introduce you with the concept and the definition of stemming. So stemming is the process of transforming to a root word. That is, it uses an algorithm that removes common word endings from English words such as ly, es, ed, and s. For example, assuming if you are performing an analysis over the words carefully, cared, cares, caringly. Now, all these words actually define care. Okay. So you are going to identify that information. So let's just go and let's get started with coding here. So here the process is stemming process. And the process actually what it does, it transforms the original text into root text by removal of affixes. Okay, that's what you guys will be doing in today. Now here, when it comes to stemming, when it comes to transformation, so you have three algorithms. The first algorithm which we have is, we call it as Porter-Stemmer algorithm. Okay, we're going to use Porter-Stemmer algorithm. Apart from Porter, there is another algorithm known as Lancaster Stemmer algorithm. And the third one is Snowball Stemmer algorithm. So all the people, those who are connected with us, you will be implementing all these three algorithms in order to identify the root word out of the word which includes affixes. So we are going to remove these affixes from the words and we'll reach out to the original meaning of that keyword, whatever is being used. Okay, so by now everybody is on Google Collaboratory, I guess. In case if you guys have any questions, feel free to ask. You can post your queries on facebook.com/Hackveda Canada. You can also visit our website hackveda.ca for Canadian and international users, as well as you can also access hackveda.in. Now here, so let's proceed to the implementation part of how stemming will be performed. So let us consider, the first step is, let's consider a text from a source. Okay. Let's say the text contains some words like the one which we have taken in the example, like caring, care, scared, carefully, careful. Okay. Careless, let's say, kind of this. So we got certain text keywords out, and now our objective is to remove the affixes and reach out to the root word. Now in order to do this, the first step, whenever we come towards performing text analysis, one of the most important library is NLTK. So we are going to import libraries, and from NLTK you will be able to import Porter Stemmer. Let's connect Google Collaboratory first so that we get suggestions. As you all can see, now our Google Collaboratory script is connected. So here, let's quickly test. So we have this Porter Stemmer. This is one algorithm which is old and most widely used algorithm when it comes to performing stemming. But there is an improved version of this algorithm available since 2001, and that is known as Snowball Stemmer. So let's add in Snowball Stemmer. And there is one more known as Lancaster Stemmer. So you will be using these three algorithms in order to implement stemming over the content which is available to you. So machine is going to extract content from PDF files, images, audio files, and whatever words have been spoken and whatever has been identified, you have got this text out of it, and out of this text we are going to remove the inflections out. Okay, guys, so here as you all can see, you have imported three algorithms. The first one is Porter algorithm, second one is Snowball algorithm, and the third one is Lancaster stemming algorithm. And again, I'm sharing you an image so as to provide you differences between all these three algorithms. So guys, you are implementing in these three algorithms for performing stemming. The first one is written by Martin Porter in 1979, which is oldest and widely used, and it is computationally intensive algorithm. And there is an improved version of this algorithm available known as Snowball algorithm, which is again written by Martin Porter along with Richard Bolton in 2001. In commercial applications, Snowball is most generally used. So you will get to know today how you can quickly implement Snowball algorithm in order to identify the root word. Apart from these two algorithms, there is one more algorithm written by Krish D. Pace in 1990, and name of the algorithm is known as Lancaster. But there was always problem because this algorithm is fast and aggressive, as well as the words are not intuitive for shorter words. But for your complete experience, we will be working out with all these three algorithms, and whichever suits best, we are going to use it. Okay, please acknowledge me on chat if everybody is able to follow. If you guys have any questions till now, feel free to ask. I will answer your questions. Okay, great. So I've got messages and let's just continue further from here. So guys, you all will be implementing these 3 algorithms and let's just get back to the code. So here, in order to use Porter, Lancaster and Snowball, we have included these libraries from NLTK package. Now what next we are going to do? When it comes to performing stemming, the first step is to identify tokens. Get tokens from statements. So in order to get word tokens from statements, what all we can do? We can import word tokenize from NLTK. So we're going to use from NLTK import word tokenize. Okay, you can use word tokenize. So let's use this function word tokenize, and word tokenize is going to give you tokens out of the text content: caring, care, scared, carefully, careful, careless. So let's just drop in text here in the function and let's run it. So when you do that, you can see that out of your string caring, care, scared, carefully, careless, we have got these words filtered out: caring, care, scared, carefully, careful, careless. Okay, so this is step number 1, wherein you got tokens from statements. Okay, now I have already told you all, in case if you guys miss anything, like if you get an error or if you land up into any errors, you have to download punctuations, as well as it may be asked to download words or whatever it is. So that's going to be displayed to you in the last line of your error code in case if anybody gets any error while execution. So it's always a good idea to import nltk.download, and you can quickly take up punctuations, which is an important file when it comes to word tokenization. So let's run it and you're going to get the output somewhat like this. So it is nltk.download. You need to import libraries. So let's just import NLTK as well. So you can do these 2 steps: import NLTK, and using NLTK you can download punctuations. Okay, so as you all can see, package punctuation is already up to date on my machine, and I have got these tokens filtered out. Now when you got the tokens, what will you be doing in? So second step is to perform stemming. Okay, let's say perform stemming on a word token. To perform stemming, we will be going by all the algorithms like Porter stemmer, Lancaster stemmer, and then the best one, Snowball stemmer. Let's do that. To use Porter stemmer, just call the class Porter stemmer and let's save it into an object stemmer1, let's say. Or else you can also name it like Porter underscore stemmer. So what this Porter stemmer is going to do, it is going to identify your keyword out of the word token, and then it is going to remove the inflection. Now when it comes to stemming, using this object Porter underscore stemmer, there is a function known as stem, which we all use. So before using stem, let us just run the cell so that we get the object Porter stemmer created. And now what am I going to do? I'm going to show you help of the stem function. Porter stemmer dot stem. So that's the function, which is pretty important. So now when it comes to stemming, you're going to strip affixes from the token and return the stem. So let's say you're going to have a statement you have converted into tokens. Now this word token is going to be stemmed. Now when it comes to stemming, affixes will be stripped out and the left out stem will be returned back. Okay. Now just to have a quick test of how this works. So let's say if I type in a keyword, wherein you can see that stem will only work on one single keyword. So you cannot pass a list, you cannot pass a dictionary, tuple or anything like that. You have to pass a single word whose stem or root word you want to identify. Now, I hope everybody is able to do that. So let's go for it. Let's stem the token by providing the word. And let's say I am providing a word known as, let's say, carefully. Okay. Or let's say cared, somewhat like this. So I've executed Porter stemmer, and now you can see that even if I performed stemming on the keyword stemmer, on the keyword cared, out of this execution, I have got this result. So now what you're going to do, your objective is okay, we'll come to that point. Okay guys, so I hope you guys have executed till now. You are able to perform stemming on a word token. Now our objective is to take up multiple keywords and to bring out their stemmed keyword or the root keyword out of those text content. And as I can see here, I am getting a text question as well from Khalid Muhammad. In many cases, two words, even having the same root word, can have totally different meaning in different situation. So how does stemming help there? Okay, so actually it depends on case-to-case basis. Generally, when it comes to semantic relationships between the content, then in that case, there is an advanced step which we perform, that is lemmatization we do, wherein when it comes to lemmatization, what you can quickly do is you can transform your word to the dictionary based form. And there are certain options like we can use WordNet, wherein WordNet exactly is a large lexical database of English words which actually link together with respect to semantic relationships. So that's what we can do. Okay, so when it comes to lemmatization, which is going to be the next step, so what we generally do, we group together on the basis of meanings then. So Khalid, your question which you have asked, in many cases, two words even having the same root word can have totally different meaning in different situation. So when it comes to different meanings, we group words together based on their meanings and based on their semantic relationships, and that we do using lemmatizations. When it comes to stemming, then we have this limitations of transforming the words to the root keyword. Okay, now let's see. So Khalid, if your question is clear, you can let us know. Now let's take up the next step. So what we are going to do now, so we are going to read each word in the content, and then we are going to identify the root keyword out of the text content, and we are going to see how and what Porter stemmer is going to return us. So let's go for it. In step 3, let's say, or let's call it as step 2A, perform stemming on word tokens. Okay, so what we are going to do, let's tokenize it. Let's go for word tokenize. We have already used word tokenize above. So here, what we are going to do, to tokenize that again, and I'm going to store that into word tokens. So we are going to extract the word tokens out of the text content. So you can see that we have caring, cares, cared, carefully, careful, careless. And now what we are going to do, we are going to perform stemming on all of these keywords available in word tokens. So let me just print that so that it will be easy for us to compare. Now here what we are going to do, let's write in a for loop. So we'll define somewhat like this for word and word tokens. Okay, or let's say for token in word tokens, we're going to read out each word token out of the word tokens list, and then we are going to perform stemming on it. So what I'll be doing is, let us just keep that into root words by Porter. So I'm going to make a list of Porter root word. So I'm going to make an empty list of Porter root words, and I'm going to add in each root word identified by Porter algorithm, and I'm going to store that onto this list Porter root words. So let's use Porter stemmer. So out of Porter stemmer, you're going to perform this stem function. You're going to stem the token. Then you're going to save it onto Porter stem word. Okay. Let's call it as Porter root word. Every individual word we're going to identify. And let's put it onto this list. Porter underscore root underscore words dot append. We're going to add these words onto this list, and I'm going to add in each root word. Okay. So I'm going to identify these root words. And now, out of the loop, let me just print all the words which we have identified using the Porter root words. So there is this option over the string. You can execute this function join, which is going to convert all the elements from a list into a string representation. So we are going to join each word in the Porter root words, and we're going to print that content out. So now let's have a look. So when you run this, so here you can see that you have got these root words out. So you have got care, 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 careless. Okay. And let's just define one more thing. So here I'm going to define these will be the Porter words. Porter root words. And above this we will be having the original text as well. Let's just do it here. So let's print the original words, and I'm going to print in text here, just so as to have this comparison. So guys, you can see that we had certain words wherein we had caring, cares, cared, carefully, careful, careless. And out of this, majority of the words like have been identified, wherein you can see that Porter stemming has actually extracted the root word out of the content. Okay. But since it is widely used, but there were certain limitations to Porter root words algorithm. So then what Porter did, he combined with this guy known as Richard Bolton in 2001, wherein they brought Snowball algorithm. So when it comes to Snowball algorithm is an improved version of Porter's original stemming algorithm. So let us quickly see how we are going to use it. Now in the same way, we got Porter root words. Let's get Snowball root words extracted out of the content. So let's go to the for loop. And this time we need to use another stemmer. And this stemmer is going to be your Snowball stemmer. So let's use Snowball stemmer. You can see that above we have already imported Snowball stemmer. Okay. And what we are going to do, let's just quickly create and use other stemmers which you need in. So let's just add in Snowball stemmer. So we are going to save that onto Snowball stemmer. Okay. And let's say at the same time, let's also use Lancaster stemmer so that we can have a quick comparison among all these stemming algorithms which is available. Lancaster stemmer. Okay. Now, so we have imported these stemmers as well, and we have created objects for these stemming algorithms also, so that we will be using them and we'll have a quick comparison. So I created snowball root words here, and let's perform that. So I'm going to use snowball stemmer. We are going to execute this function stem, and we are going to define the token, and I'm going to store that onto snowball stem or root word. Okay, and then I'm going to append all these root word into the list snowball root words. So let's do it. Snowball underscore root underscore words dot append, and I'm going to append snowball root word. Okay, and let's print the content out for snowball root word. So let's just join that and quickly extract that out. Snowball root words. We're going to extract the content out, which has been implemented using snowball root algorithms. Let's quickly run it. So when we run, it is asking one argument. So when it comes to using snowball algorithm, you also need to specify an argument known as language when you are creating this object. Okay. So here you can quickly see that if you land up into any exceptions sometimes, so how to tackle over it. You can quickly go to the last line, to the type error, wherein you can see that while initialization, there is one more parameter which was required, and the parameter was language. And this occurred on this line, which is line number 16. Okay, so snowball stemmer actually needs a language as well. So let us define that. So when it comes to defining, let's quickly go back at the top at snowball stemmer, and let's define language. And the language which we are using is English. Let's run it. So now when you run, you get that algorithm executed, and snowball root words have also been able to identify that with accuracy. So careless is like is not an affix, it's like a word actually. So to avoid confusion, we can actually remove careless from here. Okay, let's run it. Okay, so for that, what we can do is you can quickly check that with something like carelessly, something like this. And I need to check the correct spelling of carelessly. I'm so sorry. Let's say carelessly. Yeah. Okay. So let's just type in carelessly, something like this, and let's run this so as to have understanding of that keyword also. Now, so let's run it. So here you can see that. So when it comes to carelessly, so actual keyword is careless, the root keyword is careless. So somehow Porter algorithm was like a little inaccurate in extraction of in stemming. So when it comes to carelessly word, it was not able to identify that. But since you have this improved version of Porter's algorithm available, so it was able to identify the root word appropriately. Okay, so that's how what you can do is you can perform stemming, wherein you can quickly remove the affix out of the text strings and the tokens which are available to you. Now, Let's quickly go back to the top and let's quickly test that with Lancaster algorithm also. So Lancaster algorithm was written by Krish D. Pace in 1990. And this algorithm is fast and aggressive algorithm. However, stemmed words are not intuitive for shorter words. So let's try that also. So we have already initialized Lancaster stemmer. Just we need to create in a list of root words created by Lancaster stemmer. So we'll go to Lancaster root words. We're going to make a list of Lancaster root words. Let's go to the for loop and let's quickly define. So I'm going to use Lancaster stemmer. We're going to call this function stem. We're going to provide in token, and we're going to store that onto Lancaster root word. Okay. Now, when you got this Lancaster root word, you're going to append them to Lancaster root words list, and I'm going to add in this keyword Lancaster root word. Okay. So we have also used Lancaster algorithm, wherein you can quickly print and quickly identify Lancaster root words. Going to join this list, and this is Lancaster root words. So guys, now as you can see, we are going to quickly test that and we will quickly have a comparison. So Lancaster was introduced in 1990, so it's inferior to Snowball when it comes to commercial applications. So generally, Snowball algorithm is used. Okay. So as you all can see, many commercial companies have been using stemming since 1980s and have produced algorithmic and lexical stemmers in many languages. The Snowball stemmers have been compared with commercial lexical stemmers with varying results. So here you can see that you can quickly go to these articles wherein you can refer to how stemming has been done. And Google search adopted stemming in 2003. Previously, a search for fish would not have returned fishing. Okay, but nowadays what can happen is, even if you are like searching for a word, so what Google can do is it can perform stemming over the word which you have defined in, and it can identify the correct keyword, the root word, and then it can perform the search. And depending on the frequency of words available, priority of your rank based pages can be returned back to you. So other software search algorithms vary in their use of word stemming. Programs that simply search for substrings obviously will find fish in fishing, but when searching for fishes will not find occurrences of the word fish. So hence you can see stemming is important. Okay, so search is like one important area segment wherein stemming is generally used. And now let me just quickly take you back here. So guys, as you can see, we have got this Lancaster keywords as well. And now let's quickly add in these 2-3 more keywords. So let's say somebody has searched for, let's say, fishing, fishes, and now we need to identify, are these stemming algorithms able to identify the right root word so as to perform the right search? So let's quickly search for it. When you run this algorithm, now what happened at the end? So here, these are the algorithms which have given you certain good results. So Porter was able to identify using fishing. He was able to identify the root word fish, and out of the original word fishes, it was able to identify that the context of this keyword and the root word is fish. So accordingly, search can be performed. And here how you can see that Snowball is like much more effective in identifying the keywords. Lancaster is fast and aggressive, but somewhat it's intuitive for shorter words. But when it comes to longer words and when it comes to highly accurate thing, so Porter's algorithm with the algorithm written along with Richard Bolton in 2001 seems to be one of the most useful algorithm in performing stemming. And I think you guys also got to know about why stemming is important. So when it comes to on Google, you actually try to define various words. So carefully, fishing, fishes, whenever you do that. So what Google does, it's not going to exactly go and match fishes only. So it's going to identify the root word and then it is going to perform the search. And all the relevant content related to whatever word you have typed in, you're going to grab that unstructured information or the raw information out of the web pages. Okay. So that's how we use the algorithms of stemming, wherein important concepts of Porter algorithms, Snowball algorithms, and Lancaster algorithms are implemented in. And you can actually transform your original word into the stemmed word or to the root word. So that's where stemming is actually pretty useful. So guys, as of now, you guys are aware about how you can quickly extract content out of any media. In previous sessions, I have already told you that how you can extract content from audio, how you can extract content from images, how you can extract content from PDF files. Post that, I have told you how you can convert those text content into tokens like sentence tokens and word tokens. Then I have shown you how you can remove numbers out of it, how you can remove stop words out of it, how you can remove punctuations out of it, how you can remove white spaces out of it. Now, after doing all that stuff, you now understand how you can perform stemming as well. So when it comes to stemming, you can quickly reach out to the root word so as to understand the meaning. And when you understand the right root word, then your search and your pattern identification will be more appropriate. Okay, so there was certain comparison which has been identified. So there are certain research papers available over here, which you can quickly refer to identify the differences between how your stemming algorithm using Snowball has been compared with other lexical algorithms so as to identify the right stem. Now, so this process was actually known as stemming process. Now, apart from stemming process, there are certain things wherein you can quickly transform the words on the basis of dictionary-based form. And for that, what we do is we generally use the concepts of WordNet, which is a large lexical database for English words, which is linked together by the semantic relationships. It groups together your words on the basis of their meanings. And for that, we generally use WordNet lemmatizer, which you will be exploring as soon as we would be progressing further in our course. So when it comes to semantic analysis, you will be performing lemmatization, and post lemmatization, then there will be certain more concepts wherein you will be performing n-grams, wherein you will actually identify a set of co-occurring or continuous sequences of n items from a given sequence of large text. So that is also going to be pretty helpful for you. And apart from that, apart from n-grams, then we have bag of words concepts available, and you will be able to identify this information in a rich extraction part, and then you will be able to explore it. Okay, so that's what we will be doing in as soon as we will be progressing. So till now, you guys let me know how many of you have attempted this and how many of you have got the correct response. Okay, so I've got a message from Karan. Done. That's great, Karan. So have you understood the concept that why stemming is important and how Google uses it? Great, great, great. So guys, all the people, those who are connected with us on Facebook, if you have any questions, you can quickly reach out to us and you can quickly ask your queries. Moreover, we have a pool of sessions conducted on unsupervised machine learning, wherein we had a lot of great, we have done a lot of great steps and processes in order to extract data from different sources and performing data pre-processing on it. And still we are onto the data pre-processing phase, wherein we explored a lot of ways, and post that we will be proceeding to data exploration. You will be performing data modeling so that you can filter sentiments out of the content, what's being written and how it's happening. So that's the thing. So you'll be doing all this stuff as soon as we'll be progressing further, and you will be working out on some real-time great content projects. So I got a question here from Andreas Brennick. What is stemming? For what is this good? Okay, so Brennick, let me just give you an example. So let's say when it comes to, let's say, Google, okay? So let's say if you try to search for fishing, okay, you're going to get some information filtered wherein your keywords like fishing has been used, wherein it actually tries to identify the content that this is with respect to something with respect to fishes or fish. In the same way, in case if you search for this term like fishes, okay, so again the content which you are getting here, you can see that Google has returned you a result like how to put new fish into a fish tank. Okay, so now you can quickly observe here, you searched for fishes, but Google is responding you this content which includes fish. Okay, so how Google has become so intelligent that he identified that fishes is not the original word. So Google identified this process that the root word for fishes is this term fish. Okay, and this process of identification of root words out of the general terms is known as stemming. And why is it good? So it is good because when we perform unsupervised machine learning, what we want is we want to write a software program which can actually read the text content, which can read natural language written by a user on Facebook or on Twitter. And after reading that text content, machine should be able to understand what this guy is saying or what is the sentiment of the text which he has written. So stemming is that process using which you can actually identify what is the meaning of a specific term which you are writing, and you can reach out to the root word. And there are many more examples which you can explore on Wikipedia. So Andreas Brunnick, if you have got this query clear, That's pretty good. Moreover, in case if you are interested in learning how data science analysis, machine learning is done using Python programming, you can reach out to our website, hackveda.ca or hackveda.in, and you can register for our membership, which is available at a very highly discounted price as of now. So you can reach out to our website, register, and you can get started learning machine learning and data science with us using Python programming. And you will be able to perform machine learning for artificial intelligence and a lot more things. So guys, in case if there is any query from anyone, please post your queries here. As well as in the next section of this training, we will be working out on lemmatization, wherein you will be actually working on identification of the words depending on the semantic relationships. So there's a good question from Drew Down. Does stemming work only for the English language or can be adapted to other native languages? So see, you can actually adapt it to other native languages as well, but it depends what grammar you're using. So it's totally a natural language processing is a grammar based game. So it depends on how much grammar you have developed for a specific language. And definitely this can be adapted to other native languages, and people are working on natural language processing wherein they are actually trying to perform all these stages of understanding the words and identifying the tokens and removing the punctuations, understanding the semantics, understanding the meanings in different languages. So a lot of work is going on, and only the accuracy comes into consideration as of now, how highly accurate they are. But when it comes to English, since a lot of work has already been done from quite a long time, so it's much easy in English language so as to implement all these steps and in order to understand what the content signifies. But when it comes to other native languages, then a lot of work is going on, and yes, there are options wherein you can quickly process different types of languages. So here some examples of what kind of languages and what kind of information, what kind of languages are actually being taken. So that's IBM Watson text to speech example, which I would like to share with all of you. So here is this example, Watson text to speech. Sorry, that should be speech to text. Let me just take you back. Speech to text. So here there is a service by IBM Watson, wherein they are working on a lot of languages. Let's just quickly go there. I may need to sign in for this, but you all can quickly try that. Earlier I have signed in on this website, but let's quickly go and view the demo. Yeah, so here you will get a demonstration, and you can see that. So IBM is working on speech to text kind of whenever somebody records an audio in different languages like Arabic, English, Spanish, French, Brazilian, Portuguese, Japanese, Korean, German, Mandarin. So text content can be extracted from these audio files, and then different processes of removing the noise and understanding tokens and performing removal of punctuations and removal of other stop words and stemming lematizations, all those things can be done into the native languages also. Now, in case if there is any query, let me know. Otherwise, we are good to go. So that's all for today's session on stemming, wherein you guys got to know about how you can quickly read text content, how you can convert it into tokens. And once you have got each word token, you can quickly identify the root word out of it. So when you get to know the root word, then you can refer to a dictionary base wherein you can quickly understand what is the meaning of that particular content, and that we will be doing in our next session that we will be organizing from 6 p.m. to 8 p.m. tomorrow evening. In order to have access to that session, guys, reach out to our website hackveda.in and you can register for a program. You can take up this membership. International users, those who do not stay in India, can reach out to our website hackveda.ca, or else you can also speak to us at admin@hackveda.ca as well as admin@hackveda.in. When you reach out to hackveda.ca or hackveda.in website, you can also open Talk to Mentor and you can speak to us regarding joining the program. And when you reach out to our website, this is this program, Data Science, Machine Learning, Deep Learning, which is actually available at a discounted price as of now at just INR 5900. So you guys can quickly take up this opportunity. You can go to this website, you can register your information, and our representatives will get in touch with you and they will make you admitted to the course, and then you can join these series live with us in a live classroom wherein you can discuss your projects and doubts with us as well, and you're going to get a curated text Talk to Mentor support with respect to implementations of concepts as well as implementations of your projects. So guys, as of now, I'm sharing my script code to all of you so that you all can quickly access that. It's available on collab.research.google.com, and we'll be having our further session tomorrow evening, 6 p.m. to 8 p.m. Indian Standard Time, and 7:30 a.m. to 9:30 a.m. EST, Eastern Standard Time. Thank you so much for being available. Thank you so much for watching.